In the previous session, we have looked at binomial series, both for finite and infinite in abstract. So now let's look at some problem solving. So first one is, we are given 1 by 6 plus 1 by 6 times 4 by 12 x plus 1 by 6 times 4 by 12 times 7 by 18 x square and so on. We have to figure out that this is the binomial expansion of what expression. So here the series does not start with 1. So we factor out common factor 1 by 6. When we do that, we get that 1. So now focusing on the bracketed expression, we notice that the numerator of the nth term is 4, 7, 10 and so on is in AP with a common difference of q equal to 3. Let m be equal to n minus 1. So the general term is t sub m is equal to 4 times 7 times and so on up to 4 plus 3m divided by 6 to the power of m times m factorial times x to the power of m. The reason we took m equal to n minus 1 is to make sure that this power is the same as the power of x. Okay, so now we split 6 to the power of m as 2 to the power of m times 3 to the power of m. Our general term will become t sub m is equal to 4 times 7 times and so on up to 4 plus 3m divided by 2 to the power of m times 3 to the power of m times m factorial times x to the power of m. So now we take 3 to the power of m to the numerator. So 4 by 3 times 7 by 3 times dot times 4 plus 3m by 3. The whole thing divided by 2 to the power of m times m factorial times x to the power of m. Why did we take 3 to the power of m up? Mainly because the common difference is 3. We take this 2 to the power of m and absorb it into x to the power of m. So we get x by 2 to the power of m. Since the numerator is a product of rising factors starting with 4 by 3, that means p by q is equal to 4 by 3. Note that p by q equal to 4 by 3, which is a rational. The numerator has a rising factors. There is no extra factor of the form minus 1 to the power of n. Which means the series is of the form 1 minus t to the power of minus p by q. Therefore, s is equal to 1 by 6 times 1 minus x by 2 to the power of p by q, that is minus 4 by 3. So here t is x by 2 and p by q is minus 4 by 3. P by q is actually 4 by 3, but because it is of the form 1 minus t to the power of minus p by q, we write it as minus 4 by 3. This infinite series is convergent when the absolute value of x by 2 is less than 1, which implies magnitude of x is less than 2. So the radius of convergence r is equal to 2. This series can also be written as 1 by 6 times the summation n equal to 0 to infinity of the binomial coefficient 4 by 3 plus n minus 1 n times x by 2 to the power of n. Simplifying this, we get 1 by 6 times summation n equal to 0 to infinity of the binomial coefficient n plus 1 by 3 n times x by 2 to the power of n. Second is s is equal to 1 plus 7 by 16 times x plus 7 by 16 times 21 by 32 times x square plus 7 by 16 times 21 by 32 times 35 by 48 times x cube and so on. Denominators are multiples of 16, that is 16, 32, 48 up to 16n. So this can be written as 16 to the power of n times n factorial. Numerator starts with p equal to 7 and is in AP with common difference q equal to 14. So for n greater than or equal to 0, the coefficient of x to the power of n is 7 times, 21 times, 35 times, and so on up to 7 plus 14 n minus 1 divided by 16 to the power of n times n factorial. Now, note that 16 to the power of n, that 16 is not 14. So in the numerator, we should have 14 in the denominator of each of the factors of the numerator. So we multiply it by 14 to the power of n times 7 by 14 times 21 by 14 times 35 by 14 dot 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 7 plus 14 n minus 1 divided by 14. The whole thing divided by 16 to the power of n times n factorial. This is properly arranged as per the binomial theorem. But we have extra terms, 14 to the power of n and 16 to the power of n. That we take it along with x. So we have this expression times 14x by 16 to the power of n. So here now, the first term of the AP would be 7 by 14, which is equal to 1 by 2. And hence P by Q equal to 1 by 2. So again, P by Q equal to 1 by 2, which is rational. The numerator has rising factors. There is no extra factor of the form minus 1 to the power of n. So, which means the series is of the form 1 minus t to the power of minus p by q. Hence, we have s is equal to 1 minus the x coefficient of x, that is 14 by 16. Simplifying it, we get 7 by 8 x to the power of p by q, rather minus p by q. So, we get minus 1 by 2. The series is convergent when 7 by 8x absolute value is less than 1, which implies magnitude of x is less than 8 by 7. And this again can be written in a much more compact form. So summation n equal to 0 to infinity of 1 by 2 plus n minus 1 n, the binomial coefficient, times 7x by 8 to the power of n. Simplifying this, we get summation n equal to 0 to infinity of n minus half n times 7x by 8 to the power of n. That was our second problem. Here we have s is equal to 1 minus 7 by 16x plus 7 by 16 times 21 by 32 x square minus 7 by 16 times 21 by 32 times 35 by 48 x cube and so on. Same problem as the previous, but with alternating signs. So there will be an extra factor minus 1 to the power of n minus 1. Now the factors in the numerator is an AP with p equal to 7 and q equal to 14. We have seen this already. The denominator is a multiple of 16. So p equal to 7, q equal to 14, p by q equal to 1 by 2. Note that p by q equal to 1 by 2, which is a rational. The numerator has rising factors. There is an extra factor of the form minus 1 to the power of n. Hence corresponds to 1 plus t to the power of minus p by q. S is equal to 1 plus 7 by 8x to the power of minus 1 by 2. So series S is convergent when 7x by 8 absolute value is less than 1, which implies when absolute value of x is less than 8 by 7. And the compressed form is summation n equal to 0 to infinity of minus 1 to the power of n times n minus half choose n times 7x by 8 to the power of n. Fourth one. Now s is equal to 3 by 50 times x plus 3 by 50 times 18 by 100 x square plus 3 by 50 times 18 by 100 times 33 by 150 x cube and so on. So the series does not start with 1. Let us add 1 to the series and subtract 1 later. So we have s is equal to 1 which we have added now, 1 plus 3 by 50 times x plus 3 by 50 times 18 by 100 x square, and so on. And finally, we subtract 1. Now, focusing on only on the series. The factors in the numerator are in AP, 3, 18, 33, and so on, starting with 3 and with common difference 15. So the coefficient of x to the power of n is 3 times 18 times 33 times and so on up to 3 plus 15 times n minus 1 divided by 50 times 100 times 150 and so on. Dividing the factors in the numerator by the common difference. And of course, balancing it by multiplying it by 15 to the power of n. We get 15 to the power of n times 3 by 15 times 18 by 15 times 33 by 15 and so on times 3 plus 15 n minus 1 by 15, the whole thing divided by 50 to the power of n times n factorial. So we are trying to map it to the standard binomial form. So here 15 to the power of n we have, 50 to the power of n we have, we take it into x. We get 15x by 50 to the power of n. Simplifying this, we get 1 by 5 times 6 by 5 times 11 by 5 and so on up to 1 plus 5 times n minus 1 by 5. The whole thing divided by n factorial times 3x by 10 to the power of n. So note that p by q is equal to 1 by 5, which is a rational. The numerator has rising factors. There is no extra factor of the form minus 1 to the power of n. So hence corresponds to 1 minus t to the power of minus p by q. So we have s is equal to 1 minus 3x by 10 to the power of minus 1 by 5 minus 1. And the compressed form is this. Now let's look at the fifth sum. S is equal to 1 plus 4 by 3 times 6 x plus 4 times 3 by 3 times 6 times 9 x square and so on. Now here the denominators are 3, 6, 9 product up to 3n, which can be written as 3 to the power of n times n factorial. And the numerator, that is p times p minus q times p minus qq and so on, is 4 times 3 times 2 times 1. So common difference equal to minus 1, which implies q is equal to 1 and first term p is equal to 4. So coefficient of x to the power of n is 4 factorial divided by 4 minus n factorial times 1 by 3 to the power of n times n factorial. Now, if we take n factorial along with 4 minus n factorial, we get 4 choose n times 1 by 3 to the power of n, which can also be written as 4cn times 1 by 3 to the power of n. Since p is equal to 4 and the numerator is falling by 1, implies p by q is equal to 4, which is in positive integers. So it is of the form 1 plus t to the power of 4, a positive integer, a finite binomial. Now we have to figure out t. So x to the power of n divided by 3 to the power of n is equal to x by 3 to the power of n, which implies t is equal to x by 3. So hence s is equal to summation n equal to 0 to 4 of 4cn times x by 3 to the power of n, which is equal to 1 plus x by 3 to the power of 4. Now it may look very complicated, but remember most of the steps can be done in our mind itself. So instead of doing all the steps, you can see that the numerator stops once it hits 0, which means it is a finite binomial. Taking the denominator as 3 to the power of n times n factorial, we arrive at t is equal to x by 3. Coefficient of x to the power of n is 4 factorial by 4 minus n factorial times 1 by 3 to the power of n times n factorial, which gives us 4c n times 1 by 3 to the power of n. So we arrive at s is equal to 1 plus x by 3 to the power of 4. So this is the steps that we need to write if many of the steps we are doing it in our mind. This is the full. That was some problem solving using binomial series. Now, if you found this useful, please do like, share, and subscribe. Questions, suggestions are always welcome. Thanks for watching. See you in the next session. That's it for now.